Page 319, number 21, gives us the equation y equals x squared and y equals 4. And the area that's going to be bounded by those two lines is going to be that yellow area that I've shaded in here. And the question asks us to rotate this around the x-axis. And when we do that, we're going to generate this solid that I've outlined here in green. So the first thing is, because we're rotating around the x-axis, we want to make sure that we're going to slice it in the right direction. So I'm going to slice it vertically here. And each one of these slices is going to generate a cross-sectional area. And we're going to have a width of dx. Okay, so that's one thing. Now, when we think about the cross-sectional area, it's going to be a circle with a hole in it or a washer. So to do that, we need to then, to work out the area, the cross-sectional area we want, we're going to take the big circle and subtract the small circle area. So we take the big circle area minus the small circle area. To get the big circle area, I need the radius of that big circle. Now the radius is constant because the outside edge is always y equals 5. So the green line here represents my big circle radius. So I'm going to start calculating my area here. My area expression is going to be my big circle, so the radius squared times pi for the big circle, that's the area. And I also want to take away the area of that small circle, so I need the small radius. If I take a look at the diagram, that red line is going to give me the inside radius. Well, the height of that red line is going to be my y value, and that's being the radius, I can get that as x squared. So the area of the smaller circle, which I'm going to take away, is going to be the radius, which is x squared, squared times pi. So then I'm just going to simplify this expression. This works out to be 16. I'm going to factor out the pi. 16 pi minus, and this becomes x to the power 4, and again we factored out the pi. So once we have the cross-sectional area, I can now calculate volume. I'm going to calculate my volume by giving that area some width or some thickness, and that thickness is going to be dx. And because of the function, the area is calculated using x, it's consistent with my dx, so I don't have to mess around with my equations. So my volume is going to look like this. Pi r squared minus pi r squared is going to be 16 minus x to the power 4. And then I'm going to give that some thickness dx. And I'm going to integrate this from the x-axis. My intersection values are -2 to +2. So there is my expression that will calculate the volume of this three-dimensional object. So I'm going to anti-differentiate this. So I end up with 16x minus x to the power 5, x5 over 5, and integrating this from -2 to +2. Substituting in my values here, I get 32 minus, this is going to be power 5, so 32 over 5. And then I'm going to subtract, well, this works out to be -32 plus 32 over 5. Okay, so then when I put this together, I'm going to end up with 64 minus, so minus 32 minus, so -60, minus 64 over 5. So working that out, this is going to end up being 320 over 5 minus 64 over 5. So I end up with 320 minus 64 is going to give me 256 pi over 5. and that's going to be units cubed. So taking a look at my answers here, it's going to end up being 256 over pi over 5, so the answer is C.